Hello, you absolute legends. We're going to calculate the equilibrium constant for this reaction. This is nitrogen gas combining with 3 equivalents of hydrogen gas to form ammonia, NH3. And we have a balanced chemical reaction here. This is a combination reaction. So to calculate the equilibrium constant, we need to know the molarities. We know some stuff about this reaction right here. So we're told that at equilibrium, after about 7-8 minutes have passed, that we have 0.15 molarity of nitrogen gas. We have 0.35 molarity of hydrogen gas present, and we have 0.25 molarity of ammonia present at equilibrium. To calculate the equilibrium constant, capital K, let's write the generic form using the balanced chemical reaction, and then we'll plug in the numbers as they see fit. So the form of any capital K expression has the molarities of the products on the top and the molarities of the reactants at the bottom. We only have one product, NH3, and from the balanced chemical reaction, this coefficient 2 becomes a superscript squared. The reactants on the bottom, N2 and H2 go on the bottom, and again, so this is cubed. Now, square brackets mean something very specific in chemistry. Square brackets is hieroglyphics for molarity, capital M. And capital M molarity can break down more usefully into moles divided by liters. So if I were to say this over the phone, I would say that the equilibrium constant, capital K, equals the molarity of NH3 squared divided by the product of the molarity of N2 and H2 cubed. So now that we have the generic form for this specific chemical reaction, let's fill in the numbers and solve for capital K. So NH3, we're told the molarity is 0.25. For N2, don't forget the squares, those baby numbers. For the N2, we're told the molarity is 0.15. And for the H2, we're told the molarity is 0.35 cubed. Now I dropped the units from these numbers of 0.25, 15, and 35 because formally the capital K number doesn't have any units. So I've just dropped the units ahead of time. Any other time you've seen me do scaffolds or division or multiplication, I've kept the units. But something specific for capital K is it has no units. This is really just a math problem now. I have to multiply and divide, making sure I follow my order of operations to solve for capital K. I'm going to piecemeal this out and do things one at a time. So 0.25 times squared is 0.0625. 0.35 cubed (0.0429). 0.15 times 0.0429. 0.006. So now just divide these numbers by each other. This looks like it's going to be around 10, 9. .76. So for this particular reaction, at this particular temperature, whatever this temperature was, this is the equilibrium constant for this reaction. I hope this helps. Thank you.